Okay, so where did the parent graphs come from? They came from what we understood about the unit circle. And we know the unit circle completes in 2 pi. And we said that was a complete period. And so when we went to graph this, we said it'll make a nice pretty graph if we make that 4th tick mark the period length. So we have positive 2 pi on this side, negative 2 pi on this side. So this would be pi, this would be pi over 2, this would be 3 pi over 2. Now, with the parent graph, it matches up quite nicely with what we already know about the unit circle. Okay, so at 0, which is on the vertical axis, at 0, 0 is here. What is the sign of 0 radians? What is the y value here? 0. That's why there's a point here.
Okay.
Because the y value at 0 is 0. Okay? Now let's go to pi over 2. This is pi over 2. What is the y value here? 1. That's why at pi over 2 we go up to 1.
There's an amplitude that would just be up to it.
Okay? Now this is pi. So what is the y value here at pi?
0.
0. So we're back here. What is the y value down here at 3 pi over 2? Negative 1. So we're down here. What is the y value at 2 pi? 0. This is why our function looks like this. It comes from the y values, which is what sine is, of the unit circle.
So it does start.
Okay? So, and then it just continues, the pattern continues this way, but it would make sense. If we went back, if we went negative pi over 2, the y value is negative 1. Well, there it is. If we went negative pi, the y value is 0. There it is. If we went negative 3 pi over 2, the y value is 1. There it is. And that's our parent graph for sine. So, the goal was not for you to memorize what happens, but to understand what's going on. Why is it placed here? Now, Colin said, well, if this amplitude changes, that just changes the height of the wave. So now we go up and down 2. We multiply that value by 2. Okay? All right, now let's do cosine. Same idea, but when we go to look at the unit circle, what are we looking at?
X's.
Yeah, good enough. We're looking at the x's. Oh.
You can twist.
I just want to stretch it. Okay. So this is going to be 2 pi. This is pi. This is pi over 2. So with the parent graph, it doesn't change. Now, if we cause horizontal stretches or compressions, these 4 tick marks change, don't they?
Yes.
C.
All right. So this time, instead of looking at the y's, we look at the x's because cosine is the x value on the unit circle.
I actually remember that.
So what is the x value right here at 0 radians? 1. What is the x value right here at pi over 2 radians?
0.
0. What is the x value here at pi?
Negative 1.
Negative 1. The x value here is
0.
0. The x value here is 1. And if we went backwards, negative pi over 2, what's the x value?
Negative 1. 0. Maybe. Negative 1.
The x value is 0.
Okay.
What is the x value here at negative pi?
Negative 1.
Negative 1. What is the x value here at negative 3 pi over 2?
0.
0. And then the x value is positive 1. So this is what our graph does. So we don't memorize anything, we understand. Oh, okay, the unit circle you had to memorize. You are correct. You are correct.
That was close.
Okay. So, with all of that, it should make these easier. And I'm going to go over number 5.
Alright.
So, number 5 is cosine. It is shifted up to, so I'm going to give myself a little more room up top.
That's perfect. That's really nice.
It's better than normal, that's for sure. All right, now this equation was not in the form that I like. So I do a little work to get it in that form. No, I didn't have to. Just like when we have a horizontal shift with our x, we always do the opposite. If the vertical shift is over with the y, you would do the opposite. But that's what happens when you move it to the end. So, I like, which you do not have to have, I like the b factored out. So if we factored this out, what would this be?
Pi over 4.
Dividing out 2 is like multiplying by 1/2, so that makes that pi over 4. Now you don't have to do that, certainly. If you left it in there to find that we would just, when we work on our period, we would, and to find this shift, we would just take this and divide it by that. All right, so the amplitude is actually a positive 1. That negative out in front causes that reflection. Okay, the period, normal period for cosine is 2 pi. So we do 2 pi divided by b, so it is just pi. Horizontal shift is going to be negative pi over 4. Vertical shift is going to be up 2. Okay, so we're going to go ahead and identify how we are counting. I generally make this fourth one the period. So in this case it'd be pi. This would be pi over 2. This would be pi over 4. And this is 3 pi over 4. Very good. Now I said generally because it's not always helpful. And we'll talk about that on this one. All right, and then I graph the midline. It is not a necessary part of the graph, but it is for me. It makes me graph it correctly. So the vertical shift causes that midline to go up 2 units. So up 2 units. There we go. Now it shifts back to where I'm starting here. Now let's think about cosine. Here, 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 here. X values. 1, 0, negative 1, 0. But this one has a negative out in front. So instead of starting up 1, we're going to start down 1. So, and then back to 0, and then instead of down 1, we go up 1. And then back to 0, and then down 1. And back to 0, and we continue the pattern. Once we get a couple of them, we should have it.
I don't like the horizontal shifts.
That's what I got right
Okay? Now, if you look at this one, this fourth one is the period, 8 pi. But that didn't help me because I had a horizontal shift of 1 pi. And my first one was 2 pi. So what I did was I went back and divided all these in half. Does that make sense?
Yeah, that's what I did.
So that I could get that shift in there. Because otherwise I wouldn't have that shift. So now I'm starting back pi. And then I have to go over 2, so I'm going to be halfway in between every time. Halfway in between every time.
If we just put them halfway between without.
Then you're good. If you do them halfway in between and you only label these,
Okay.
you are just fine.
Oh yeah, that's what I did.
Yeah,
Okay, cool.
yeah.
I just didn't know if that was like
I'm actually getting the hang of it.
Yes. All right.
Oh, wait, never mind. I did that wrong.
Okay. Now on this one, there are two forms we could look at for the equation. One where the b is in here and you have to factor it out. I like it best. This is where Mr. Campbell and I have a different preference. I like the b factored out.
I did too. It's easy.
I like it factored out. He leaves it in. Doesn't matter. They're both correct. But in this form, C by itself is your phase shift or your horizontal shift. But in this form, it's not.
You could divide it.
It would be C over B is that phase shift. So it just depends on what form you leave your answer in as to what you would identify these as. So you could leave it like this or like this. These are both correct. They are both correct. Two correct forms of the right answer. All right, how'd you do on the, okay. All right, and then what happened?
That was
Then we crashed and burned, didn't we?
Oh, yes.
All right, so let's talk about 10. All right, so we start with reading the problem, as we do anytime we have a word problem. Suppose that a water wheel with a radius of 7 rotates at 6 revs per minute in a counterclockwise direction. 2 seconds after you start a stopwatch, point P on the rim of the wheel is at its greatest height, which is a distance of 13 feet above the water. The center of the wheel is 6 feet above the surface. Okay, so part A asks us to draw a picture. Well, one, I'm not good at circles, so let's go use a circle tool. All right, there we go. And then I'm going to put a center to my circle. Somewhat accurate. And then this is a water wheel, so obviously it's sitting in the water so that it can scoop it up, right?
Oh,
Okay.
it's not. I put mine on top of the water. So it's like,
Okay, so,
Did you read the column?
yes.
all right. So it tells us that the radius is 7 feet. You really kind of had to understand that a water wheel would go into the water. Otherwise it would
Why
work.
it was 6 feet above the water?
That's
right.
The radius was 30.
So it did say the center was 6 feet above the water. So we know that this is 6. So it leaves 1 foot under the water right here.
See.
That makes so much more sense.
Okay?
That's all like USB
Alright.
electricity.
Then it tells us that there is a point P that is the highest point. So obviously it's up here. And it says that point P is 13 feet. Now I would probably make this 0, 13. Up 13.
No, but it moved 2 seconds.
It will move. You are correct. It's going to move. Okay. All right. So, and what did you say at 2 seconds?
At 2
2 seconds. So let's say time of 2 seconds. All right. They also told us about the revs per minute, but then they gave us time in seconds. So I'm probably going to do a little stoke. So multiply this by 1 minute and 60 seconds to do the conversion here. So I get 66 over 60 revs per second. So basically that tells me I can do 1 revolution in 10 seconds. Are you with me?
That's very slow.
All right. So, it is slow. Water wheels don't sling. They do kind of go slow. Now, how can I want to convert this to, they asked me to write this as a sinusoidal curve. So I'm converting this to trig. So I'm thinking about what this is going to do as it goes around. So can I kind of do like this and divide it up like the unit circle that I know and love? Yeah, I can. I sure can. So, if this point occurred 2 seconds after we started this stopwatch, but it takes 10 seconds to go completely around to get back to here, how many seconds did I divide this up into?
2.5.
Very good. So, between here and here is 2.5 seconds. So, what would the time be there?
5.
You have Julian Moore in it?
You have Julian
Okay.
for trash? Good. You can write whatever.
Okay. So, we said if it takes 10 seconds and we're dividing this up into 4 quadrants, then this would take 2.5 seconds to go from here to here. Okay? So the time at this point would be 4.5 seconds because we were at 2 right here. So 2 plus 2.5 is 4.5. What would the time at this position be?
7.
7 seconds. What would the time at this position be? 9.5. And to get all the way back to where we started, what would the time be? 12. 12 seconds. 12 seconds. Okay, because it took us 10 seconds to complete 1 revolution. So if I divided that revolution into 4 equal parts, each turn would take 2.5 seconds. Does that make sense? All right, so now we can graph it.
Yes.
Okay, so now we're going to graph it, and I'm going to come look at it forward so it's not crooked and y'all panic.
It's fine.
It's better.
It's better than normal? Okay,
It's fine.
this is a little off. We'll fix it just a hair. And now it's a little the other way. There we go. Okay, so
One way, right?
I'm going to go with the time that I've notated on my water wheel already. So it started at 2 seconds.
Right.
But then the next one is 4.5. So this isn't an equal interval here. This one's slightly smaller than this one. Then my next interval takes me out to 7, and then 9.5, and then 12. And this axis represents time in seconds, right? All right. Guys, where does the midline go? Yeah.
The midline.
Halfway between the peaks
It
and
does. Where is the center?
At 6.
At 6.
That's a straight line right there.
Okay. So our midline is going to be here at a height of 6 feet. Where would the crest of this wave lie? At 13. Where would the trough of this wave lie? At -1. Yeah. Okay. So I know I'm going to go up to 13, and I'm going to come down to -1. Okay, at 2 seconds, just looking at my picture, I should be up here at 13 feet. And then at 4.5 seconds, I'm at 6 feet. And then at 7 seconds, I am down to -1. At 9.5 seconds, I am back up to 6. And at 12 seconds, I am back up to 13.
So,
Okay.
is there going to be something like this in the test? Or
There will be, but obviously we're going to practice. This was your first one.
first Ferris wheel?
I know how to do it. The word problems mess me up sometimes.
When I when I did the equation, it
Math.
didn't turn out to the graph, so I did the equation.
Math just makes me angry.
Okay,
Why would
Okay,
you make
look at it.
one?
I don't know how this is.
Because that's where he goes under.
so there we go.
Muy bien.
All right, so now we have to write the equation. This was A, this was B, this is C. Now, and as for sinusoidal curve, we know we can write sine and cosine are somewhat interchangeable. Sine is actually more difficult on this one. And cosine, in terms of this problem, actually makes a little more sense.
Yeah.
So,
It's a B.
if I was picking, I would choose cosine. Okay? We'll do cosine and then we'll talk about what you would have to do to write it as a sine curve.
You have to make it left one, right?
Okay, there are some things that we need to write an equation. We need to know amplitude. Right? We need to know period.
Amplitude 7.
We need to know horizontal/phase shift. And we need to know vertical shift.
Period.
Okay, amplitude is 7. We'll come back to period. Horizontal shift.
2.
If we're speaking in terms of cosine, you are correct. It has been shifted here because we're starting with a high point.
So 2.
So this would be 2. Vertical shift. Where is the midline?
6.
At 6. Okay, now period. What is a normal period? We know a normal period for sine and cosine is 2 pi. But this period is not normal. This period, how long does it take it to complete a cycle? From 2 to 12 is 10. So where did we get the 10 from? 10 seconds to complete
So 2.
one revolution.
So 2.
So we have to solve for B. Remember, normal period is 2 pi, but to find the period, we do 2 pi divided by B. Well, 2 pi divided by B has to equal 10, and then we solve for B, which you're correct. So we're going to solve for B here. So we get B times 2 pi equals 10. So B equals, nope, the B is here, not there. So 2 pi divided by 10, correct, is B. So this is pi over 5. You can see where that comes from. All right.
I agree with that.
So amplitude is 7.
The period's 10.
Not okay. The period is 10 seconds. You are correct. B is pi over 5. There we go. So pi over 5 goes here. Guys, I messed this up. The period is actually 10 seconds.
Okay.
So we didn't need to find.
So we had to solve for B, though, to get the equation. Okay? And then minus the horizontal shift plus the vertical shift.
Which I got right.
So, if you like having the B factored out, it would look like that. If you are more comfortable with it not factored out,
This will do.
it would look like this. Yes, sir.
If we were taking a test, could we do it like vice versa? But man, I know like I'm pretty like inconsistent. Like I might do it one way, then the next problem I might do it the other way. Is that okay?
That's okay, because most of the time my brain is just fine figuring out. As long as it's right,
Alright.
I'm happy.
Figure out when you got it wrong.
That was
Okay.
last year.
All right. Now, D. We've got an equation we're working with. D. How high above or below the water's surface will the point be at 17.5 seconds? What can we do?
Plug in.
We can plug it in. Plug in 17.5. I'd like everyone to get out their calculator right now and plug in 17.5.
I knew that because
Yes, you do. Because we're about to graph something.
I love that.
Oh, I think I may have left my calculator here on the day of the exam. Did you find one?
There is a $10 storage fee,
What?
but I
Only
can
have a
check and
20.
see if I have one.
Yeah, I got a 99. Yep.
I got 91. I was pretty proud of myself.
Wait,
Wait, so you were here, but you didn't see him?
Well, we're sitting next to each other. What are you talking about? Like, literally.
Wow.
I remember Haley and Julian and you were here. Yeah, I
I got 105 out of 40.
I got 93.77. Same.
Negative 0.
She was technically the one, because I didn't fail that.
No, there were 4.
I did a sine function, but it's same person.
I got a 0.
One of them was like,
Could you take it? Could you just-
All right, so I got this.
93.
Wait, hold up.
What'd you get?
How?
Not bad.
Not that.
Not that you get like 12 points up?
No.
Yeah, that's what I got 12
You
points.
got 93.78.
Okay.
I got 12.
So 2 things you gotta do. You gotta check your parentheses. On your calculator, it opens up a set right here. So you need an extra set. So you'll need an extra set right there. Now the second thing. Are we in degrees or radians for this problem?
radius.
Radians.
Yeah, I'm
So
in
what
radians.
does your calculator have to be?
Radiant. Hold on. Mine's in radiant.
I'm in radius. I'm in radius too. Yeah, what do you mean? Check mine. Talk about
Same thing. Yeah, we did the exact same thing.
Wait, Miss Willoughby, did you find the calculator though?
What if Miss Willoughby was in degrees? Wait, Miss Willoughby, how do you make it the sign though? 'Cause the palm
I am so confused.
Oh my god.
I said that
Oh, I
Ruby's
got it.
starting
I got it.
math. It's gonna be like
I did not.
doing math class today. I don't want to
Come on,
lie.
donkey. How was that completed?
Look how I changed the parentheses.
LN.
Are you still going?
Alright, well,
Just
I'm not working with Kim.
Oh, okay. We didn't do the parentheses.
Oh,
right.
got it right.
She got a bracket.
Those are parentheses, Julian. They're just bigger.
They're parentheses.
Bang. Watch this. Cosine of pi. 2. Watch this. 2. 3.
All right. Now the second part of this problem asks when it goes up and when it goes down. All right. So up. So up would be from like 0 to here. That's going up. So it's going up from 0 to 2. And it goes up again from 7 to 12. Y'all see that's where it's going up? Okay. And it's going down. We're about to graph it, yeah, because we have to answer the next question. It goes down from 2 to 7. And then we can see it starts to go down here after 12, can't we? It's going to go down from 12 to what?
17.
Yes, it is. It's periodic.
Oh, I actually got
So
that.
we could continue these indefinitely. Good.
Plus
But that's good enough. All right, now the last part, part E. Part E asks us, at what positive time t was point P first emerging from the water? So let's take a look at our graph and make sure we understand that is this point right here. So this is where it goes down into the water. This is where it emerges from the water.
That's the exact one.
How can I find this point?
Find the 0.
Find the 0. So now we do need to graph it. Okay? So go ahead, pull out your calculator, and let's graph it together. Hold on, let's see. Okay, so if you have like a Zoom 6 going on, this is what you can see. We cannot see the peaks, we cannot see the crest, but we can see the trough. This is that point we're looking for, which is a 0. So what would we do? We would hit second, trace, choice 2. We would go left side, enter, right side, enter, hit enter for guess, and there it is. So at 7.86 seconds is where point P would first emerge from the water. Yes, sir.
My graph's just a line.
Yeah,
Did you do the
you didn't put
geometry?
17.5 in, did you?
That's not what.
No.
That's not.
No.
Is that why we
Oh.
Right. That's the equation.
Oh, I just saw that. I was waiting.
Yeah, because if you're doing that, then you only get 1 point.
Yeah, I got a pretty fine.
That was closer than yours.
No.
Yeah, I just
Way closer.
What was the answer to this week?
But Mark was like,
7.86.
7.86.
I think I'm actually starting to get this.
Cool.
I am too.
All right. So some of you wrote this as sine. All right. So if I was to try to model this function using sine, so here we said the time was approximately 7.86 seconds.
I put 7.
7.861. Yes. Okay, so if we were going to model this using sine instead of cosine, cosine actually naturally fits this curve better, so cosine would be a good choice. But if we were going to do sine, I would shift to here. Or you could start here
and do negative.
and do a negative sign.
Oh, I added 1/2.
And if you do negative,
So then it starts.
He moved it that way.
So you moved it left
Yeah, if
and started here. That's another possibility.
it was half
Okay?
this and half
So we would start in any of those places. Would the amplitude change? No. With the period, would your B change? No. Just your shift. So if you did move it back, which would be the easiest thing to do,
left or right.
so you did right, a left, a half? Yeah. That is one. Or this could be here with minus 4.5, but a negative out in front. Or it could be here, minus 9.5 with no negative. So there's many different ways we can model it with sine or cosine. But cosine actually fits this problem better because it has us start with that peak, which is where the problem started. Does that make sense? Okay, so we do need more practice though. So guess what you have for homework?
Practice.
Practice!
I guessed it right.